This is a review for your exponential functions test. Calculator is allowed on this entire test, so keep that in mind. Remember, if you're doing this at home, that you can always use Desmos as a calculator. Hassan invested $100,000 at the end of 1981. He lets the interest compound at 8% daily. Write a function representing how much his investment will be worth after X years. All right, so his principal is $100,000. We know that it is compounded daily, so N will be 365, and it's 8%, which is 0.08 as your rate. Your compound interest formula is the amount is equal to your principal times 1 plus R over N to the NT. This is on the board, will be on the board whenever you're taking your test. So your principal, 100,000, times, this is A equals this, sorry, and then 1 plus your rate, 0.08, divided by daily is 365. To the 365, we don't know time, that is going to be X. How much will his invested be worth by 2008? So 2008 minus 1981, that is going to be 27 years. So we're going to plug an X, 27 in for X. So we're going to have 100,000. 1 plus 0.08 divided by 365 to the 365 times 27, and that is $866,908.56. Now we want to know how much, this is his investment, how much his investment will be worth. We know that his principal was 100,000, so if we subtract 100,000, that gives us an interest of $766,908.56. All right, given the exponential function 2 times 3 to the x plus 4 minus 1, answer the following questions. All right, so we're going to complete the table and sketch this. So I'm going to go to y equals and type this in, 2 times 3 to the x plus 4. Minus 1 is back down on the main line. I'm going to go to my table, and I'm going to write down points that I might be able to plot. So I can see negative 6 is negative 0.7778, negative 5 is negative 0.333, negative 4 is 1, negative 3 is 5, negative 2 is 17, and if I trace that, this is just a standard window. Remember, you can go to Zoom 6 to get a standard window. And I'm going to sketch that. So negative 4, 2, 3, and 1, negative 3 and 5. That right there. Negative 5 and negative 1/3. Negative 6 and negative 0.7. So I have a horizontal asymptote down here, and there's my graph. Compared with the 3 to the x, what transformations have happened? Alright, so you have 3 different transformations. You have this minus 1, this plus 4, and the 2. Multiplying by 2 is a vertical stretch of 2. Plus 4 will move it left 4, and the minus 1 would move it down 1. You can also graph 3 to the x and compare them, but you usually can get the left and right, up and down, but the stretches are going to make it a little bit more difficult. So my suggestion is to look at these and know your transformations. Alright, then D, is this function example of exponential growth or decay? So it is growth because it's increasing, and we can know that from the equation because our basis, our A is positive and our exponent is positive. Number 3, a culture containing 300 bacteria doubles every hour. Write a function representing the population for every hour that passes. So you start off with your initial amount. So we're looking at y is equal to a and then b to the x. So 300. And it is doubling, so that's going to be 2 to the x. If it were tripling, that'd be 3 to the x. Predict the number of bacteria after 12 hours. So that's going to be 300 times 2 to the 12. And that is 1,228,800. Given the graph, the function to the right, for what values of x is x greater than or equal to 24? That should be f of x greater than or equal to 24. Alright, so draw a line where your y is 24. So our x values for which it's greater than 24 all over here are going to be when x is greater than or equal to -1. Number 5, which type of transformation can be used to obtain the graph g of x is equal to 1/3 to the x from the graph of g of x equal to 2x? So I've got a 1/3 out front. That is a vertical compression. It's a compression because that number is between 0 and 1 of 1/3. If it were larger than 1, it would be a vertical stretch. So know your transformations. Number 6, a factory begins producing new parts. Data was collected on the number of defective parts per 10,000 parts produced. The graph shown displays some of the data for the first 10 weeks of production. Based on the graph, fill in the missing data. Okay, so we have week 1, we have week 2, we don't have week 3. It's probably, and what I'd do is I'd sketch a smooth curve and then put my points where they cross. So I put that one, that could be a little bit better. So I put that one right about there. I'd have a point right about here, a point right about here, and a point right about here. And if they're asking about one of those points in specific, once you've drawn that smooth curve, go up and look at it. So week 8 would be 80. Alright, number 7, find the value of the following expression. So you're going to have a little bit of review of your radicals and rational exponents. So remember that the top number is your power and the bottom number is your root. So this is going to be the 4th root of 81 to the 5th power. The 4th root of 81 is 3. 3 to the 5th is 243. 25 to the -1/2. Alright, negative exponents mean to take your have 1 over, the reciprocal, and the 1/2 means to take the square root. So that's going to be 1 over the square root of 25. Not right now. Alright, and the square root of 25 is 5, so 1 over 5. Let's solve for x. So 2 to the 3x is equal to 32 to the 5 minus x. So 32 is 2 to the 5th. So I'm going to have 2 to the 3x is equal to 2 to the 5 times 5 minus x. Once you have a common base, then you're setting your exponents equal. So you're going to have 3x equals 25 minus 5x. Add 5x to both sides. 8x is equal to 25. Divide by 8. X equals 25 over 8. Number 10, you have the same base, so you just set the exponents equal. X plus 1 is equal to 2x minus 1. So I'm going to subtract x and add 1. So I get 2 is equal to x. Alright, number 11. Anytime you have the same base, you're going to add the exponents. So 5 to the, and when you add fractions, you add their numerators. So 5 and 3 is 8. Your denominator stays the same, so 8 over 2. So that'd be 5 to the 4th. 5 times 5 is 25. 25 times 5 is 125. And 125 times 5 is 625. You can also use your calculator because this whole test is calculator. Alright, solve the following equation. So square root of b plus 15 is equal to square root of 3b plus 1. You can set your parts underneath the square root equal. So b plus 15 equals 3b plus 1. I'm going to subtract 3b at the same time I subtract 15. So that gives me negative 2b is equal to negative 14. Divide by negative 2. B is 7. Alright, letter B. Okay, so I need to get my radical by itself, so I'm going to subtract 11 from both sides. That gives me the fourth root of 2x minus 1 equals 15 minus 11 is 4. Then I'm going to raise both sides to the fourth power. So 2x minus 1 equals, and 4 to the fourth is 256. I used my calculator to do that. Then I'm going to add 1. So I have 2x is equal to 257. Divide by 2. X is equal to, that's 1, goes in there twice, goes in 17 8 times, 128.5. Number 14. The number of farms in Iowa in thousands can be modeled by N of t is equal to 119 to the times 0.987t, where t is the number of years since 1980. Has the number of farms in Iowa been increasing or decreasing? So to see whether it's increasing or decreasing, we're looking at this number right here. If it is greater than 1, it's increasing. Less than 1, it is decreasing. So this is decreasing. According to the model, will the number of farms be about 100,000? So we're wanting to know, this is modeled in thousands, so we're wanting to know when 100 is equal to 119 times 0.987 to the t. So I'm going to put this in y1 and this in y2. So y1, clear, 100, and then in y2 I'm going to have 119 times 0.987 to the x. Now I want to be able to see up that high, so I'm going to have to change my window. And I'm going to change my window so that I can see my y maxes up to 150. And my x maxes, I'm going to change them to 20. I might have to change that again, but that's a good starting spot. So there is my line at 100,000. And there is my exponential decay. I want to find out where they intersect, so I'm going to go second calc. Choose number 5, which says intersect. Arrow close to the intersection point, and then I'm going to hit enter 3 times. And I'm only looking at the x value here, so that is 13, because I'm looking for what year, or sorry, when. So 1980 plus my x value is 13 would be 1993. How does a graph of a parent function differ from that of a specific function? Okay, remember the parent function is before the transformation. It's a graph before any transformations. So before it gets moved left, right, up, down, or reflected or stretched. It's a graph before any transformations. Number 16. An antibiotic is introduced into a colony of 12,000 bacteria during a lab experiment. The function n of m is equal to 12,000 times 0.851 to the m divided by 10 can be used to model the bacteria in the colony after m minutes. Which value is closest to the amount of time for the population to drop to 6,000? So I'm wanting to know when this is equal to 6,000. So again, go into my calculator, 6,000, and then 12,000, 0.851 to the x power, or sorry, x divided by 10. Now I'm going to need to be able to see higher because I'm going to need to be able to see up to 12,000. So I'm going back to window. I'm going to change my y max to, or sorry, I need to be able to see 6,000. I'm going to change it to 10,000. Trace it. I think I typed something in wrong. Yep, I tapped 1,200 instead of 12,000. I'm going to add a 0, then trace it again. Alright, so I can see that it's going to cross, but I can't see far enough to the right. So I'm going to go to my window, change my X max to 100, see if I can see it then. Perfect. I can see where they intersect right there. So I'm going second calc, intersect. I'm pretty close to it already. Hit enter 3 times, and that is 42.96. I'm going to go 43 minutes. Number 17. There were 400 cell phones sold in an electronics store in January. Since then, cell phone sales at this store have increased at a rate of 6% per month. At this rate of growth, which function can be used to determine the monthly cell phone sales in months after January? Alright, so we know that we started off with 400. So I'm looking at my exponential growth model. So that is y is equal to a times 1 plus my rate as a decimal to t. A is my initial amount, so I'm going to have y is equal to 400, 1 plus, and 6% is 0.06 as a decimal to the t. I could also write that as 400 and then 1.06 to the t. This is the end of your review.